quick recap of today's notes on composite functions and operations on functions. I'm going to be using some colors here to color code this, so if you have colors handy, that would be helpful to you as well. So the first thing that's important to note is what the different notation means and not to get confused by what you're seeing. So first, when I have f plus g of x, that simply means I'm adding my f function and my g function. I've got two different functions and I'm adding them together. Same story for difference. I'm subtracting them. Okay. Product, you're usually going to see a tiny little dot between the f and the g actually, and you're just going to be multiplying your f and your g, whatever they may be. And then quotient, of course, is dividing. Now the new one that might be kind of tricky to get the hang of is going to be composition of functions. And what this means is I'm going to substitute one of my functions into the variable of the other. So this is where order matters. We read this as f of g of x. So that little open circle means that I'm going to plug in g in place of my variable in my f function. And we'll see that in practice here in a little bit. So first, starting with this example 1, I'm going to color code my functions because I do have 4 of them here. So I've got f, g, h, and k. And the first thing it wants me to do is find the domain of each function. So starting with f of x, I have a radical, and we cannot take the square root of a negative number. So my x values have to be within the range that I don't end up with a negative number inside of my radical. So where we find this turnaround point is we have to find what would make the number inside our radical 0. And here that's going to be when x is equal to 5. And any number greater than that, it's going to stay positive. If I have a number smaller than that, I'm going to get a negative. So 5 is my cutoff point. And I can take the negative of 0, sorry, not the negative, the square root of 0, because the square root of 0 is 0. So 5 is going to be included in my domain. So it's going to be all values greater than 5. And I wrote that backwards. As I wrote my inequality sign the wrong way. X can be greater than or equal to 5 for f of x. For g of x, I have x in my denominator, and the restriction there is that I cannot divide by 0, so x cannot be 0. It can be any other number but not 0 because I can't divide by 0. Then h, there are no restrictions on what x can be, so my domain is all real numbers, negative infinity to positive infinity. Same thing with k. There's no restrictions there on what x can or can't be, so my domain is all real numbers. Moving on, part B. Now remember, we don't want to get tripped up by this notation. This is just the sum of my two functions. We're looking at h of x and k of x. So remember, that is my green and my blue. So I'm just going to have 2x squared plus 3x minus 1 plus 4x minus 5. I'm going to combine my like terms, and I'll get 2x squared plus 7x minus 6. Then part C, this is the product. So this is going to be h of x times k of x. And again, this is my green and my blue. And I'm going to be multiplying them together. Now what I have here is a trinomial multiplied by a binomial. So I'm going to have to do multiplication 6 times. I'm going to take each piece of my binomial and multiply it by my trinomial. So the 4x times the 3 pieces, then the minus 5 times the 3 pieces. So we're doing multiplication 6 times. So first, 4x and 2x squared is going to give me 8x cubed. 4x and 3x will be 12x squared. 4x and minus 1, minus 4x. Then the negative 5 times 2x squared will give me negative 10x squared. Negative 5 times 3x is minus 15x. And then negative 5 times negative 1 gives me positive 5. And then lastly, again, I'm just going to combine my like terms. And I'm running out of room here a little bit. And that's my resulting function. Okay. D, again, this is just f of x plus g of x, and this here is my yellow and my orange function from the top. So I'm going to have square root of x minus 5 plus negative 3 over x, and because I have plus a negative, that's just going to be square root of x minus 5 minus 3 over x. F minus g of x, we're just subtracting our functions. This is still my orange and my yellow. So square root of x minus 5 minus negative 3 over x, and I have minus a negative, so that becomes plus positive. So square root of x minus 5 plus 3 over x. Okay. And then my last two at the bottom, this is going to be f of x times g of x, still working with our same yellow and orange. X minus 5 square root times negative 3 over x. Now this is the same thing as the square root of x minus 5 over 1, so visually this makes it easier to understand how I'm going to multiply. And I'm just going to make this two fractions, so top times top and bottom times bottom. And we're just going to leave it like that. And then we have quotient, so this is going to be f of x divided by g of x. Again, we're really liking that yellow and orange. So we're going to divide. And I'm going to make this into a fraction again, because when I'm dividing here, I'm going to use my keep, change, flip technique. Keep the first fraction, change that to a multiplication sign, and flip my second fraction. And again, it's just multiplying top times top, bottom times bottom. Okay. Moving on to the second page. This is more practice for the actual composition, which is like that newer technique we're using here. So when I'm taking f of x, that means that whatever I put inside this parentheses here, I'm going to be substituting for x here. So that could be the number 2. It could be the variable, that's a lowercase a, if this will focus, come on. It could be the expression x plus 2, or it could be the expression x plus h. It really could be anything. So again, remember, f of x is 4x minus 1. If I'm told g of x is equal to x plus 2, and I want to find f of g of x, that means I'm going to be finding f of x plus 2, which means I'm going to plug in x plus 2 to my function f of x. And so you'll distribute your 4 and combine like terms. So it's not quite as hard as it appears, but let's practice some more. Let's color code. I'm going to do green for f and blue for g. So find the composition of f for f of g of x. So again, that remembers f of g of x. So I'm going to find f of, my g of x here is 9 minus x squared. So here in place of x, I'm going to plug in the square root of 9 minus x squared, and I'm going to solve. When I square a square root, that cancels, and so we're left with 9 minus x squared minus 9. My 9's cancel, and my final composition is negative x squared. And the domain of that is all real numbers. There's nothing it can't be because I don't have a radical or x in my denominator. Okay. Let's practice that one more time. I'm going to skip part A here. Color code. And now here's where it's really important to the order, because previously I was finding f of g of x. Here I'm looking for g of f of x because the g is listed first. So I'm looking for g of x plus 3. So I'm going to be plugging that in twice because I have two x's in my g of x. So x plus 3 squared minus 2 times x plus 3 minus 15. So remember, this we have to FOIL. Here we distribute the minus 2, and we're going to combine our like terms. And here is our final composition. All right, and then that last page, we can also do this with a table of values. So I'm going to color code once again. This is my f function. This is my g function. So starting with A, I want to find f of 1. So that means my x value is 1, and I'm looking at my f function. So looking up here, my x value is 1 at this point, and my y value there is negative 1. Then g of negative 1, same thing. I'm going to look on my g function this time for where x is negative 1, and that's right here, and that would be negative 2. Part C, we're looking for g of f of 1. So remember, that's like writing it this way. And we want to work from the inside out here. So first we want to find f of 1, which we already did in part A. So I'm looking for g of negative 1. So I'm going to look in my g function now for negative 1, and that is negative 2. So with these types of problems, you want to work from the inside out. So now briefly, I want to go over a couple examples from your homework. So here's the homework you're doing with graphs 3 through 7, and these are not quite as tricky as they look. Starting with number 1, f plus g of negative 2. Remember, this just means that we're finding f of x plus g of x. And in this case, x equals negative 2. So I'm going to look on my graph. F of x is my solid line. So at negative 2, f of x is 0. So 0. Then g of x is my dashed line. And at negative 2, g of x is positive 2. So 0 plus 2 is 2. Okay. Number 2 is similar. We have subtraction here now. So I want to find f of negative 5. And that's my solid line. So that is positive 2. Minus g of negative 5, which is 0. 2 minus 0 is 2. Okay, not too tricky. Now 6 and 7 have tables, however, and this is the one where we want to work from the inside out. So, starting with the middle, g of 2. This is my g function. When x is 2, g is 5. So I'm now looking for f of 5. So I'm going to consult my table again for my f function, and when x is 5, g is 7. All right, number 2, again, I'm working from the inside out. First, I'm looking for f of 2. When x is 2, f is 1. And so now I'm looking for g of 1. So on my g function, when x is 1, g is 2. So it's a lot easier than it looks.